Hello, ladies and gentlemen. Today we need to take a look at solving and interpreting systems of equations. So we've been talking about solving a system of equations, especially graphically, to make sense of what a graph looks like in terms of that solution. And today we also need to do some other interpreting when it comes to special notations. So for this, you need to take a few notes here, and I'll clue you in on when that is, but mostly I just need you to watch and get used to that notation before we practice in class. So the learning objective today is that you're going to be analyzing graphs of multiple functions, which is another word for systems of equations, right? When we graph two lines, when we graph a line in a parabola or things like that. Analyzing them means answering questions about them. So the first one I want you to take a look at with me is identifying the appropriate solution for this system. And this system is a little different than the ones we were doing in class, but it's still a system of equations, right? It's still two functions that are graphed, and we're still looking for that solution. So just like we did with lines, think about where that solution would be. Now in this case, we have two spots of interest for us. Right here is an intersection point. And right here is an intersection point. You can see that the straight line here, this is his equation right here, that's the line. And then this parabola shape here, or this upside down U, this is his equation, okay? So when this happens, we're still looking at the points of intersection. It's just we may have more than one in this case. So the solutions in our situation are this point right here, which is 2, -3. And then the other point down here, which is -3, -8. So we have 2 points of intersection here. Now it does say to check to be sure that what we're seeing is correct. Oftentimes when we graph these by hand especially, not so much with technology, but sometimes these are going to intersect in places that aren't always nice integer values or nice coordinates here. And because of that, we always want to check to be sure that what we're seeing is in fact an integer and not, -3.1 or something. So to check it means I have to be sure that it works in both of my functions. Remember, one was this guy and the other one was -x² + 1. So I need to be sure that they work. Both of them work now. So back into this y = x - 5. If I plug in, I'm just going to draw a line down here. If I plug in the point 2, -3, it would look like this. -3 = 2 - 5. Is that true? Is the point 2, -3 a solution when I plug him in? Well, I get -3 = 2 - 5 is -3. Yeah, it works. So in this line, 2, -3 works. In the parabola, does 2, -3 work? Well, let's try it. We're going to plug the y where the y is, and then negative, the x value goes in. Be careful that you don't make that a -2 because the squared is done first, and then you multiply by -1. So 2 squared is 4. This would be -4 then, plus 1. Yeah, that's true as well. So this is looking like a good solution. We are seeing what we need to see on the graph. And now let's do the same thing with the point -3, -8. Let's check to see if he works. So in the line, we would plug in that -8. -8 minus -3 minus 5. Is that true? Is -8 equal to -3 - 5? Yep, he's working for the line. And now we'll try the parabola again. So -8 equals negative of the x². That's always the tricky part. And then plus 1. So -3² first is 9. Put a negative sign back on it. Is -9. Be careful because that negative is not in parentheses with the x. That doesn't mean put the negative of the x. It means negative after you square the x. All right, there. Is that true? Yep, that looks good too. So both of these are valid solutions. We are seeing what we think we see on the graph there. They are going to work in both of those equations. Let's take a look at another way we can interpret these. These are, again, a parabola and a line. We don't actually have the equation here, but we can see that the line is labeled f of x, and the parabola is labeled g of x. Remember that notation, it's just the function's name. So it says, I use the graph given, identify for what x values is this thing true. So let's start over here with A. Where is f of x greater than g of x? Now remember, f of x is the line. So it's like it's asking us, where is the line greater than the parabola, which is the U shape. So where on this graph is the line greater than the parabola? That means above the parabola. So if I were to trace along here, this spot of the line is below the blue line, right? The blue parabola line. Right about here, that line crosses that parabola, and now he's above. If I look down, he's above the parabola. All of these, look at that. That red line is above the parabola. So he is greater than the parabola there. This part right here is where he's greater than the parabola. Then once he crosses the parabola again, see now the blue is above the red? So where in the world on this graph is the line greater than the parabola? For what x values? Well, let's take a closer look at this part that we have circled here. For the x values, it would be from -3 all the way over to what x value is it when it stops being greater? Looks like 5, right? So I would say from -3 to 5. Those x values are the spots where that red line is a bigger or greater than or above the blue line. So if that's the case, let's look at part B. Well, where is the line less than the parabola then? Well, that would be on the other parts we didn't mark, right? Here's the red line being less than the parabola, and here's the red line being lower or smaller than the parabola. So where is that? Well, for what x values? This is the tricky part, because remember, lines go on and on forever here. So even though my graph stops at -10, this really could keep going super negative, right? Super duper negative. When does it ever stop? Not until negative infinity, right? Never. Okay, it keeps going on and on forever. So the x values where the line is less than the parabola would be from -infinity. That's the negative infinity sign. From -infinity to, and remember where this spot was? That's where it stopped right here. So -infinity to -3. And there's another spot. Remember up here, this is where the blue line surpassed the red line again. So the red line's less than the parabola there. So that's another spot. And we would say from 5 to, and remember there's arrows on the end of those, so we'd say from 5 to +infinity. So this idea of identifying intervals or places on the graph where things are greater than or less than, that's pretty important. Let's look at C. It says for what x values, again, is f of x equal to g of x? So this is not saying find the point of intersection, right? It didn't say find the solution. It says what x values makes this part true. So I don't want the intersection point, but I just want the x values of that point. So I would say at -3, because that's one intersection point right here. And also up here, what's the x value up here? 5. So 2 spots again. And that idea of being greater than or less than is kind of tricky. So let's look at one more to get in your notes without the whole writing the range yet or writing the interval. This is just a quick sketch in your notes. Draw the x and y axes, do a little sketch of a parabola, a little sketch of that line right there. And we're just going to place on the graph some special notations. It says place a star where f of x equals g of x. So that's saying where they're equal to each other or where they intersect. That would be right here, and that would be right here. One is not greater than the other there, but they intersect there. Then it says place a smiley face on the location where the f of x, that's the line again in this picture, is greater than the parabola. Where on this graph is the line greater than the parabola or above the parabola? So right here, here's the line, right? He's below the parabola. Here's a piece of the line. Looks like he's above the parabola there. And here's a piece of a line. He's below the parabola there. So the part where the line is greater than the parabola would be right in here. This is where you would place that smiley face, right? Right in there. So you'd have a star, a smiley face, and a star. So be thinking about how we can take a look at these graphs and analyze them for their not just intersection points, but also answering questions where things are greater than or less than. Okay, so thank you for taking this good notes here today. You didn't have to write very much, but thank you for paying close attention.